Now, once we've found the least common denominator, we want to figure out how to actually use it so that we can add or subtract our fractions as necessary. So we follow the previous steps to find the LCD. And then with each irrational expression, we want to rewrite it as a new expression that's equivalent with the common denominator. So that way we can add or subtract and simplify if possible. Now the key to getting the rational expression to be equivalent with the new common denominator is by multiplying the denominator and the numerator by whatever it's missing from the least common denominator. So let's take a look at some examples. First, we want to find and identify our least common denominator. So to get our LCD, we look at the unique factors. Our unique factors in our first are x and y, followed by a 3 in the second fraction. 3 only appears once. The highest exponent for x is the third power, and the highest exponent for y is the first power. So our least common denominator is 3 x to the third y. When we take a look at our first ratio, we see that with the LCD, it's missing a 3 as well as another x. So if we multiply the numerator and denominator by 3x, we get a new equivalent fraction, 6x, 3x to the third y. Our second fraction isn't missing anything because it has the same common denominator already, so we can just rewrite it without making any changes. Now we can go ahead and add our numerators. And since we can't factor the numerator and there's no common factors in either side, we're as simplified as we can get. For b, we notice our first denominator only has one factor of x minus 2. Our second denominator only has one factor of x minus 2, so our least common denominator is the product of those two factors. So we'll go ahead and multiply by whatever they're missing. Our first fraction is missing the x minus 2, so we multiply both sides by x minus 2. Our second fraction is missing the x plus 2 in its denominator, so we multiply top and bottom by x plus 2. Don't forget to apply your distributive property, so our equivalent first fraction becomes 3x minus 6 over the common denominator, and our second fraction becomes 2x squared plus 4x, again over the common denominator. Now that we have the common denominators, we can go ahead and combine the numerators. 3x minus 6 plus 2x squared plus 4x over the common denominator. And then we combine like terms. 2x squared plus 7x minus 6 over x minus 2, x plus 2.
Now this one's a little bit interesting, because if we take a look and we see that we don't really have a common denominator, but our denominators are already really close together. They are opposites. We have negative and positive 1, we have positive and negative x. So if we go ahead and remember that when we have opposites, if we factor out or multiply by a negative, we can end up switching the signs, and we can end up having the same expression. And so if I take one side of my equation with one of the factors, and I multiply my fraction by negative 1, since I'm multiplying by an expression that equals 1, we're not changing the value of the expression, but the benefit is that it will change the value of the denominator so that we end up having a common denominator. Because this denominator ends up being a negative 1 plus x, and using our commutative property leaves us with the same denominator of x minus 1. And then the only other thing that's going to change is our numerator will move from positive to negative. So we'll have 2x minus 6 minus negative 4 over x minus 1 and x minus 1. So since we have that common denominator, 2x minus 6 minus negative 4 over x minus 1 gives me 2x minus 2 over x minus 1. And now that it's added or subtracted, we can go ahead and factor to simplify. There's a GCF of 2. And now we see we have matching factors, leaving us with the answer of just 2. So we'll continue our pattern of factoring LCD and combining like terms. And so what I encourage you to do is pause here and try the next few on your own, and then go back through and watch to see what we did. I'm not going to spend a lot of time detailing the factoring, so if you're stuck on the factoring part and how you get the factoring, then please review previous lessons on factoring to reinforce that understanding. Our unique factors here are k plus 2, k minus 2, and k minus 1. We're going to multiply each fraction by whichever of the factors it's missing. On the left, we're missing k minus 1, and on the right, we're missing k minus 2. So we'll go ahead and distribute for each of our numerators. 5k squared minus 5k minus 2k minus 4. Left numerator and right numerator. And then we have our common denominator. Now remember, when we're subtracting, we will need to distribute that negative. We combine like terms. And we would normally see if we could factor our numerator to try and simplify, but it is prime and we're not able to factor it any further. Numerator and right numerator after we distribute, and all of this will be over our common denominator, 3x minus 2, 2x plus 1, and x minus 5. Since we're adding, we can move straight to combining like terms. And our numerator is prime, so there's no more simplification. Our LCD is x plus 1, x minus 1. The middle term already has the least common denominator, so we only need to multiply the first and the last term by the factor that they're missing. Don't forget this negative needs to be distributed. All over our common denominator. We'll go ahead and combine like terms. We'll factor out our GCF. And we have common factors, so we can completely simplify. Last but not least, we've got common factors x minus 5 and x plus 5. So we're going to multiply each side by the factor that they're missing. We'll go ahead and make sure that we distribute here. And distribute on the right. all over our common denominator. Now before we distribute this negative, it might be a little easier to combine like terms first. And then we can distribute the negative. Now we'll combine like terms again. The x squareds cancel, leaving us with, I don't know why I wrote a 4 there, 7x plus 5 over our common denominator. There's no further factoring or simplifying, so there we finish it off.